we have Professor Somesh Kumar with us. Professor Somesh Kumar is a professor of mathematics in Indian Institute of Technology, Kharagpur. Uh, he will be speaking on the cogent statement of knowledge and ideas, applications, and way forward. Let me introduce him. Professor Somesh Kumar has research interests in the area of statistical decision theory and inference. He has published more than 100 research papers in international journals. He is an elected member of the International Statistical Institute, Netherlands, National Academy of Sciences, India. He received the Platinum Jubilee Lecture Award of the Indian Science Congress Association in 2016. He also received Professor K.S. Bose Best Researcher Award from Indian Society for Probability and Statistics in 2022. His video courses on probability and statistics are very popular. He has delivered more than 150 invited lectures, talks in various national and international conferences, symposia, and workshops. Over to you, sir.
Thank you, Mahesh ji, for giving a very generous introduction of mine. I will start with a shloka. Maybe Mahesh ji can say it, sing it better. But anyway, let me just say. Yatha shikha mayuranam naganam madyo yatha tad vedang shastranam ganitam मूर्धनि वर्तते. जैसे मोरों में शिखा का और नागों में मणि का स्थान सबसे ऊपर है, वैसे ही वेदांग और शास्त्रों में गणित का स्थान सबसे ऊपर है. Actually, my topic is mathematics today, and what I just wanted to convey, I mean, there has been some sort of impression that, okay, we were good in philosophy, we were good in religion, we were good in many other areas which are of social sciences, but probably not so good in sciences, although now we have enough evidence about those things. So let me, my title I have written From Ancient to Modern. It means I want to convey some continuity of mathematics tradition in Indian civilization, starting from the very early times. And the fact that we have a shloka devoted to this, it means that yes, it is not just that there are some snippets here and there. There is a substantial body of work which continued. So I will give my perspective as well as the details. Since I am from analytics side, I generally speak with the evidence rather than saying something. So evidence of usage of ratios in construction of bricks, walls, Yajnavedis, etc., they are available in ancient texts. And we find that excavations from Harappan as well as Indus Saraswati era, they show that urban architecture used various ratios and measurements indicating mathematical abilities. So now this evidences I have taken from the work by Michel Danino, R.S. Bisht, and there are many archaeologists as well as people who worked in excavations generally, and this included a lot of European scientists, or you can say excavators, who visited India during 19th, 18th, 19th and 20th century, and they have discovered various things. And now that information or knowledge has been compiled. So I recently read the book of Michel Danino, The Lost River, that is on Saraswati, and I have collected certain mathematical contents from there. So what is striking there? So I mean, like they have now given a lot of diagrams, or you can say graphs, where they are showing the architecture of the city planning, the town planning, the houses, the palaces, the temples, and so on. What is remarkable there is that they are mostly following certain standard ratios. Now, if there is a knowledge of ratios, that means there is some sort of counting system even in that civilization. So I am starting from the Harappan civilization, what we call Harappa, Mohenjo-daro. So that is now dated to something like 5000 to 7000 BC. So that is the timeline that has been now improved upon. Earlier it was said 3000 BC and so on, but now with advanced features, advanced methods of study, it has been now dated back, dated back. So for example, street widths in Kalibangan have been found to have been arranged in arithmetic or geometric progression. You can consider it like 1.8 meter, 3.6 meter, 5.4 meter, 7.2 meter. Here I have written in the terms of meters. So actually they are not in the meters. So I will tell you later on that what is it corresponding to. But in today's measurements, if we measure, it is coming to something like this, 1.8 meters, 3.6 meter and so on. So which is almost, you can consider it as a arithmetic or a geometric progression, which is in the ratio of 1:2:3:4. Similarly, now you come to far different place. This is Kaushambi, so that is here in UP. And here they are saying a road of width 2.44 meter, it is further broadened and it has been doubled to 4.88 meter. So that means doubling concept is there. So ratio 2:1. And then if you look at Arthashastra is dated something like 300 BC kind of thing, 350 BC. So there is a lot of gap between the Harappan civilization and this one, but here if you look at the widths of streets, they are described in the unit of danda. So what is the unit of danda? Danda is usually something like a 6 feet or 1.8 meter kind of thing, and that they are considering widths of 2 danda, 4 danda, 8 danda and so on. So again it is in certain ratios. Again let us go back to Harappan phase, and in the early Harappan phase, one Harappan city which was discovered in 1970s in which is actually in Haryana, present day Haryana, in Fatehabad district, and the earliest bricks that are found there, they are in the ratios 1:2:3. And then there is a later phase there, that means there are certain houses which are dated slightly later. In the same settlement, they have found two types of houses. So some constructions they are dating little early, and there the ratios of the bricks are the length and the width and the height 1:2:3, whereas in the latter phase they are in the ratio 1:2:4. And there is another layout which is probably of a mature phase. It is of a trapezoidal shape, and there is an acropolis there which is semi-elliptical. Okay, so that means the knowledge of the structure and the stability of that the semi-elliptical structure will actually stay. So that is there. The street arrangement in these places which has been discovered, and they have been found to be mostly in the right angles, and also some of them are considered oriented in the north-south axis. And there is another small building which has been discovered there. It is having semi-elliptical shape, and inside that, so the semi-elliptical shape is not a coincidence. Actually inside there is a fire altar, and that is actually also having similar shape. So that means there is a thinking behind that kind of thing. And many other structures are seen to be in fixed ratios. So I have just given certain examples. So actually the archaeologists who have studied it in detail, they have given for each building the ratios and all. I have just taken certain examples here. So for example, in the Mohenjo-daro, one acropolis is found. It is having ratios approximately 200 meter into 400 meter. That is the length and the width. And a similar thing, if you note here, in Kalibangan, which is far off from Mohenjo-daro, this is 120 meter by 240. So 1:2 ratio has been maintained there. There is another lower town acropolis in Kalibangan, which is found to have 3:2, that is 360 by 240 m. So that means there is some sort of continuity of proportions in various structures, like if you consider the Indus-Saraswati civilization and then the latter civilization, which you can call Indo-Gangetic civilization, there is a continuity of the thing. So This also, of course, is against the Vedic, Aryan invasion theory, because if there was Aryan invasion, then all this thing would not have been possible. There is a continuity of the tradition, so there is no foreign invasion or that kind of thing. That means the Aryas came from outside and so on. So if you look at the designs of pillars, temples, etc. in the latter day Pataliputra, there have been some excavations near Agra, in Prayagraj, etc. And they are generally found to be in the ratios 5:4, 10:8 and so on. And the buildings are mostly in the parallelogram, square or rectangular shapes. See, if mathematical knowledge was not there, then they would have simply gone with the circle and the square, because that is the simplest thing. I mean, you don't need mathematical knowledge to do that thing. The square and the circle can be done by any common person who is not having any scientific understanding. But they have used various shapes, that is parallelogram, the rectangular, and that too following certain ratios. It shows a well-developed mathematical thinking. So I have given here one table which is actually work of Michel Danino as well as R.S. Bisht, etc. And they have given various ratios which are used in Dholavira, and I have given the margin of error, because we are measuring in the present day meters or the feet, but that time they would not have used meter and feet because that was not there. So I will tell you what they actually used. So if you look at the ratios of the inner castle, that is 5:4, and here they have found the error margin to be less than 1%, it is just 0.9%. And outer castle, if you look at, that is also in the ratio 5:4 with a margin of error 2.4%. Then similarly you can see Bailey, it is 1:1 with margin of error 0%, Middletown 7:6, 0.5%, ceremonial ground 6:1, 0.7%, and so on. So these you can see, and if you look at this right column, in the right column you can see that the error margins are, except one place, it is always less than 1%. The length of the Middletown and so on. Similarly in the Lothal also, so the Lothal town itself, it is observed to be 280 meter to 225 meter, and there are other structures there which are also. Similarly, a granary found in Harappa, that is 5:4, so 50 meter by 40 meter. Another major building in Mohenjo-daro, it is seen to have 18.9 meter into 15.2 meter, which is approximately 1.25, which is 5:4. Now it is possible that the ratios which are used in the Indus-Saraswati civilizations, they might have followed religious, aesthetic or cosmological considerations, but they have been carried over in Vedic, Indo-Gangetic civilization, showing continuity of the mathematical tradition. In fact, if you see Shatpat Brahman and you look at the construction of Mahavedi described there, that is also using 5:4 in rectangular dimensions. So Shatpat Brahman is much later compared to the Harappan civilization, almost 3,000–4,000 years later. And again, if you see a slightly later, that is Shulva Sutras, and there they have considered the construction of multi-layered altars, and again they use the similar thing. I have not presented here various geometrical concepts. Actually, there is a beautiful PhD thesis from Banaras Hindu University, that is Saraswati Amma, and if you read that one, they have given the geometrical arguments about various shapes like squaring of a circle and all those problems which are studied in the modern Europe. But many of those problems are mentioned there. For example, bisecting a angle, trisecting, and many other kind of problems they have discussed there. If you look at Mahabharata Kal, in Mahabharata Kal you had famous King Drupada, that is the father of Draupadi. So again in 1900, etc., so there was an excavation. It's in a town called Farrukhabad in UP. It is on the banks of river Ganges. So the place is called Kampilya, which is mentioned in Mahabharata. So there is a palace type of a structure which is said to be palace of the king Drupada. It is called Drupada Kila. And again, the dimensions of that are also in the ratios 5:4, 7:6, and so on. So we can just say that there is a continuous tradition. So this is about the geometrical things. Let us come to the weights and measures. Now if you look at the weights and measures in the Harappan system, they have used cubes, some truncated spheres and many kind of things. And the lowest ones are below 1 gram, and they have something like 14 different weights, and they go up to beyond 10 kg. The units, either they are in the geometric progression or they are following certain arithmetico-geometric progression. So like it is 1:4, 2, 4, 8, 16, 32 and so on, or it is arithmetico-geometric 200, 320, 640 and so on. These similar series are observed in Arthashastra and many later texts. Now one can say that many of these could have come from the, say, European civilization or anywhere. But if I remember correctly, I mean, like even when we were children in village, see some village old person who is sort of uneducated person, but they will give us a puzzle to solve. And they will say that divide the number, I mean, like you should have weights in such a way that you can measure every integer unit between 1 to 100 kg using only 5 weights or 7 weights, and we used to solve that thing. And the solution was actually arithmetic, like we say, geometric progression. So 1, 2, 4, 8, 16, 32, and similarly we had for the 3, 1, 3, 6, 9, 27 and 81. So we used to have this. So this cannot come like that those persons would have known European mathematics or something. It is coming from indigenous thing, and which is because of this. So I am again showing the continuity between the Harappan civilization and the traditional Indian system, and we find amazing similarities. So if you look at the Harappan weights, I have written on the left hand column, it is showing the units during the Harappan weights, and if you compare them with the corresponding value in the grams, so that is the second column here, and you look at the corresponding thing in the traditional Indian weights, which was used till very recently. In fact, till 30 to 40 years back, these things were used, because I have actually lived in village till my class 12, and there in the village shopkeepers, they used to have this thing, I mean different units. This is called rattis and karshas, and here you compare these numbers. So 0.8525, this is 0.8375, this is 0.1705, this is 1.675, this is 3.41, this is 3.35. So that means except for certain correction, you can say the numbers are almost the same. Okay, so this is again. Now let us come to that what basic unit of measurement, like you said today you use centimeter or millimeter, and in grams you use. So what they could have, how did they come up with these measurements? That means the ratios and so on. So probably the human angul, I mean the length of the finger, probably that is most common unit of measurement. And a human angul actually measures between 1.6 to 1.9 centimeter. So if you look at that, so if I take some sort of average value, 1.76 into 108, that is 190. So that is probably 1.9 meter. Why that is occurring so often? Why not 2 meter, or why not 1 meter, or why not 1.5 meter? Something which is coming very regularly, that is in the measurements of 1.9 meter. So this calculation has been shown that it is 108 times 1.76. And then again 108 angulas are equal to 1 dhanu. So that is the bow length actually. So this is present both in the Lothal Kalibangan tradition as well as in the Arthashastra. So that means there is a gap of 3,000-4,000 years, and still the same things are being used. Now again another question is about 108. What is this number 108? We usually associate with the religious connotation, but actually it need not be religious. Actually, if you look at the distance between the sun and earth, and if you divide by the sun's diameter, so that is actually 108. Now the thing is that how you can measure, does it need very advanced tools? No. Actually you don't need very big things here. You can actually just proceed with, say, some simple geometric experiment which was done even in by Euclid or by Archimedes and so on. That means you just put a stick in the sunlight and then from there you can just measure. So it is 108 times there. So it does not require very, very great scientific things. So that means they have used this based on a scientific principle, not based on some religious principle. Later on it has been connected with the religious things, like you have 108 Upanishads and so on. Now you come back to even later time, that is Iron Pillar in Delhi. And R. Balasubramaniam of IIT Kanpur, he was professor in meteorology. He did very extensive work on that. He checked what is the metal and so on, and he did the dimensions also. So there if you look at the total length is 4 dhanus, the pillars diameters, they are 36 angulas at the bottom, on the ground it is 24 angulas, and actually it is, some part is below the ground, and then, so at the bottom it is 36 angulas, then 24 angulas at the ground, 12 angulas at the top. So again you can see the ratios are there. And if you look at the ratio of the pillars total length to the portion above the ground, that is 5:4. So these are all very, very, very interesting. And then there are studies in some Takshila constructions, some constructions in Nepal, especially in Kathmandu. Some ancient constructions are there, and there also. So I think I will just complete this part here. That I am talking about the one type of mathematics. So that means ratios which are used in the geometrical construction. So that means the ancient constructions followed geometrical principles using mathematical ratios. Okay, so that is one very important thing I think one should notice here. Now I come to another gift of India to civilization, that is the origin of modern numerals. So we are establishing that the present numeral system, decimal and place value system actually originated in India. In fact, the present development in modern science is based on the current numeral system that we use, the numbers 1 to 9 and 0, and the decimal place value system. Now it is important to note that this number system, in which every number has an absolute value as well as positional value, it evolved in India. In fact, substantial achievements in modern physics, mathematics and technology in Europe, it is started only after the Indian number system reached Europe through Arabs starting late first millennium. However, due to effect of colonization of Indian subcontinent during 18th-19th century, an impression was created that the Indian civilization lagged in scientific development, more so in mathematical sciences. However, now there is a rich catalog of findings which is stored in inscriptions, stone carvings, plaques, stamps, seals, charters, tablets, manuscripts in various parts of the country. So, and another thing is that again, the second impression that was created is that probably that after Bhaskaracharya and Madhava, again there is a gap. That means after 12th, 13th century, again there is no development. So again I will show that this is also a false statement. Actually there is a continued tradition which continues till now. Okay. I'll just show one word at the bottom which is written. It can be put equivalent to the discovery of fire and wheel in the evolution of human race. The discovery of or you can say setting up of the numeral system. And we will also show that the decimal place value system refer to the unique numbers. It is observed that the ancient Indians used very high, that is 10 is to the power 421, as well as very small, that is 7 to the power minus 10 numbers. And here I would like to present some controversial things also. One is that people wanted to appropriate the invention of modern numerals. They said that, oh, ancient Greeks they have discovered, or Egyptians, or Jews, or the Arabs. And they actually have not been able to provide any substantial evidence that those civilizations used these 10 numerals. And they also ignore certain facts that the people in ancient Greece had two different systems of numerals. One was based on the Roman system and the other one was alphabetical. which is the one used by Hebrews, that is the Jews. Both of them did not have zero as well as any place value system. So it was not possible to talk about very large or very small numbers, and the system was not much useful for advanced scientific work. However, certain absurd theories were floated regarding origin of modern numerals in the Western world. One is that from Egypt and North Africa, it was propounded that these numerals were invented by a person who was a glassmaker cum geometer from a place, Maghreb, which is a region in northern Africa, that is Algeria, Libya, Mauritania, Morocco, Tunisia. According to this theory, he created shapes of 9 numerals by inserting angles from each numbers, the number of angles being equal to the value of the numeral. So if you see this one, like 1, you write like this and put an angle here, and this 2 you write like this, like a Z, and put 2 angles here. This 3 you put in the form of straight lines joined by certain angles here. Then this 4 is represented as crossing of 2 lines, which is like a red cross, and you can put 4 angles here, and so on. So 5, 6, 7, 8, 9. So this in itself looks so absurd, but anyway, this is one of the theories. Another theory was propounded by a French author called Weizot. He published a paper in the journal Law Nature, Les Chiffres Arabes et leur origine, that means the origin of Arabian numerals. And he was apparently influenced by a writer in Genoa whose name was Catholico Militare. And according to this, the numerals were formed by number of lines being equal to the value of the numeral. So this is the way it is represented: 1, 1 line. So 2, you put 2 lines, and this red thing which I have put, it is my own thing. So that means 2 you join by a hypothetical line here, and 3 you put 3 lines, and then you join by certain hypothetical lines. So similarly 4, 5, and so on. Again, it looks very absurd. And similar theories were propounded by certain writers in Italy, Germany, and France. I am just naming them here. For example, one Italian writer, Mario Bettini, so he wrote certain thing called Aperia Universae Philosophiae Mathematica in 1642, and another person is German George Philipp Hausdorfer. He wrote something in Deloitte Mathematicae et Physicae, 1651, and it is again refers. I have put certain references here. There is a Frenchman, Georges Duhamel, and so on. So this is number of dots hypothesis. That means you put 1 dot, 2 dot, 3 dot, and so on. Another one is by some Arabian astrologer named Aben Regel, and then there is some theory propounded in Spain, France, and Germany, some another theories, so on. The problem of, so I have sourced these from certain references. There is a paper by Florian Cazori, and also there is a book by George Ifra, The Universal History of Numbers, the second volume. This describes all these things. So the problem with these hypotheses is that it appears that the shapes of numerals were designed based on a single person's thought process. Appearance of numerals have spontaneous generation and follow some perfectly logical and rational geometrical reasoning. And it is not based on any historical evidences in the form of plaques, palm leaf, manuscripts, tablets, inscriptions, etc. There is no continuity of usage in any part of the world of these types of symbols. They completely ignore that numerous shapes and the forms used in different civilizations and regions of the world. It also ignores continuous evolution of various shapes around the world. The naming of these numerals as Arabic itself is a historical blunder. It appears to have been named so that because Arabs carried from India and went to Europe. So if you look at the history, so during 7th century onwards, Arabians, they started invading other places. So like they came from Iraq, Iran, and then Afghanistan and to Indian subcontinent. And then definitely they would have traveled to and fro. So they would have gone back and then said at the same time many of them they went to Europe. They invaded Spain, Portugal, and other places. So definitely the scientific knowledge also was carried from India to Europe. So since Arabs carried it, so they started calling it Arabic numerals. However, I will show you the evidences of the writings of Arabian scholars who say that it is of Indian origin. And the most scientific argument against these to be of Arabian, Egyptian or Greek origin is that the Greeks had made great innovations in astronomy, physics, mechanics, medicine, mathematics and philosophy. If they had invented this system of numerals, they would have been able to make tremendous progress using decimal and place value system. And the fact that they used only Roman and Jews system clearly establishes that these hypotheses are absurd and they should be discarded. So now I will present certain evidences from the European and Arabian literature which establishes that the modern numeral system is from India. So I start from certain quotations starting from some European. So I think everybody knows the name of Laplace. He is the most famous French scientist because of his monumental contributions to physics, astronomy, mathematics and so many areas. So he says that the ingenious method of expressing every possible number using a set of 10 symbols, where each symbol has a place value and an absolute value, it emerged in India. See this important point. See, if you look at, say, Roman numerals, so you have 1, then you have 2, then you have 3, then you have 4. Now 4 is written differently, it is not 4 bars here, it is something called V and then you put a one I before, and if you put that I afterwards then it becomes 6, and if you don't put anything then it is 5. So what is that? So there is no absolute or place value meaning there. But here if you look at like this number which is written as 1814, so here 4 has an absolute value 4 and the place value is also 4 here. If you look at 1 here, 1 is having the absolute value 1 but the place value is 10. So this originality, this came from the Indian counting system. So this is said by Laplace in 1814, the ingenious method of expressing every possible number using a set of 10 symbols where each symbol has a place value as well as an absolute value, it emerged in India. The idea seems so simple nowadays that its significance and profound importance is no longer appreciated. Its simplicity lies in the way it facilitated the calculation and placed arithmetic foremost among useful inventions. The importance of this invention is more readily appreciated when one considers that it was beyond the two greatest men of antiquity, that is Archimedes and Apollonius. Then I have written actually many quotations from various European scientists. One of them is Montucla. So in 1798 he wrote a big book, it is called Historis des Mathematics. And here he says the ingenious number system which serves as the basic for modern arithmetic was used by Arabs long before it reached Europe. It would be a mistake, however, to believe that this invention is Arabic. There is a great deal of evidence, much of it provided by the Arabs themselves, that this arithmetic originated in India. And then you have John Wallis. John Wallis is one of the most famous original British mathematicians. And in 1695 he wrote a big volume called Opera Mathematica, and he refers to the 9 numerals as Indian numerals. In fact, John Wallis is one of the founders of Royal Society, and Newton actually read his mathematics before developing his own. Then Italian mathematician Cattaneo, who lived from 1510 to 74, and he wrote a book in 1546, and he says the 9 figures of India, Le now figure degli Indi. Then you have German scholar Jodok Willich, who lived from 1501 to 1552, and he wrote a book in 1540 where he says Ziffre Indice, that is the Indian figures. One of the oldest known arithmetic tracts in English, that is called The Craft of Number. See, this is written in a different, the craft of numbers, but it is written as The Craft of Numbering. So this is written differently, but that is the ancient English. 1350, it says furthermore the most, so you cannot read this thing because it is written in the original English style, that in this craft being used 10 figures as here been written. For example, 098, 7 is written differently, 654321, in which we use 10 figures of Inde. So he clearly says that these are from India. Then another Danish scholar, it is called Petrich of Dacia. He worked in Paris and Italy. He was one of the faculty members in the University of Bologna. University of Bologna is one of the most ancient universities in the modern Europe, which started in 12th century. So he wrote a commentary on a work entitled Algorithms by Sacro Bosco, that not every number can be represented in the Indian figures, which is actually a wrong statement, but he talks about anyway Indian figures. Then there is a Byzantine monk from Greece. His name is Maximus Plautus, and he composed a work called Logistic Indic, that is Indian arithmetic and the Indian way of counting. So the book was written in Greece, and here he says the great calculation according to the Indians. He says that there are only 9 figures, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this I have written in the modern form. And he further writes that a sign known as Zifra can be added to this, which according to Indians, it means nothing. The 9 figures themselves are Indians, and the Zifra is written as 0. And then you have Alexander de Villa, which is a French grammarian. The most important is Fibonacci, the Leonardo Pisano. He is one of the most significant European mathematician from 12th century. So you have this Fibonacci numbers. I think anybody who has studied little bit mathematics, you know about the Fibonacci series of numbers, where you have each number written as the sum of the preceding 2 numbers. An is equal to an minus 1 plus an minus 2. And it was developed as some sort of rabbit breeding model, the genetic model for the breeding of the rabbits and so on. And also we now call whatever is Brahmagupta Fibonacci identity. So in 1202 he wrote a book, Liber Abaci, that is the book of calculation. And in this he clearly demonstrated the usage of Indian numerals to be superior to Roman numerals. And he can be actually regarded as the first European mathematician to propound the usage of Indian numerals in the Western world. And he writes, my father was a public scribe of Bezazia, where he worked for the customs department. He asked me to learn calculations using 9 Indian figures. And he further writes, this is why that with these 9 numerals and with this sign 0, one can write all the numbers. There are many more evidences, so maybe I don't have to read each of them. This is Robert of Chester, Raymond of Toledo, Adelard of Bath, and so on. So there are so many. In fact, if you go back, I have written the earliest European reference as Vigila in 976. And he wrote a manuscript called Codex Vigilans. And here he says, the Indian race have a most subtle talent when it comes to arithmetic and other mathematical arts. And this is clear in the 9 figures with which they are able to designate each and every degree of every other numbers. And the figures look like 9, 8, 7, 6, 5, 4, 3, 2, 1. So then let us go back to the Arabian quotations, starting from the first one I have written in 1547 to 1621. So there is an Iranian scholar, and around 1600 he wrote, the title of his book is Khulasat al-Hisab, that is the quintessence of calculation. And here he writes, it was actually Indians who invented the 9 characters. Then there is another Arabian mathematician in Spain, Kala Sadi, and he wrote a commentary on a book by Ibn al-Banna, who himself was a Moroccan. And here he says the origin of these 9 figures is traditionally attributed to an Indian. Of course, this original author himself wrote that it is of Indian origin. So there are some more references. I think maybe I can just skip it. Yeah. So we have a lot of references here actually. Probably the most important is by Al-Baruni. I think everybody has heard the name of Al-Biruni, who was actually a traveler in the when this Islamic invasion was happening. So he was traveling with some of them, and he lived actually in India for almost 30 years. His timeline is 973 to 1048, and he wrote a number of books between 1010 to 1030, and one of them is called Kitab al-Argam, that is called the Book of Figures. And here he has a chapter, something is written in Arabic, so I will not read it. So what he says, arithmetic and counting using Sindh and Indian figures. Then again, Kitab fi Thaqeeq something. It says the one of the most important works about India to be written at that time. And he mentions the diversity of graphical forms of the figures used in India. Now this is another thing. See, I am simply giving certain quotations by the European and Arabic authors and so on. But what about Indian evidence itself? So after this I will present that. Okay. So, but this is mentioned by Al-Biruni himself. He mentions the diversity of the graphical forms of the figures which were used in India and insists that the figures used by Arabs originated in India. And he makes the remark, like us, the Indians use these numerical signs in their arithmetic. I have written a tract which shows in as much detail as possible how much more advanced the Indians are than we are in this field. So let us go back to evidence from a pre-Islamic Syria. So there is a Syrian bishop named Severus Sebok who studied philosophy, mathematics and astronomy at the monastery of Kanshari, which is at the banks of Euphrates. The place was exposed, so that is the modern day Iraq. In the Iraq you have this, what we used to call Dazla Farat rivers. So they are probably at the confluence of that. So he was exposed to a wealth of knowledge because the travelers like Greek travelers, Mesopotamian travelers or Indian travelers going. So that means he was exposed to many things. And he wrote a manuscript which says, the Hindus who are not even Syrians have made subtle discoveries in the field of astronomy which are even more ingenious than those of Greeks and the Babylonians as for their skillful methods of calculation and their computing which belies description. They use only 9 figures. If those who think they are the sole pioneers of science simply because they speak Greek had known of these innovations, they would have realized that there are others who speak different languages who are also knowledgeable. This evidence by Sebok, it proves that the Indian counting system was known and esteemed outside India by the middle of the 7th century. So let us look at, the continuity thing which is very important. I have shown you ratios and the geometrical constructions in the Harappan civilization and continuity in the Indo-Gangetic civilization. Okay. So when the measures are being used, so that means some method of calculation must be there. Because as I showed you, like 108 into 1.76 something. So that is coming to modern day 1.9 meter, and they have some units of that one. So how can they multiply if they don't know the number system, isn't it? So although here I am showing the current evidence which is produced by reading down the manuscripts and all which are present because the manuscripts or the palm leaves or the tablets and so on, they are at the most 2500 years old. So then if we read that one, then we will say, okay, 100 years back the number evolved and okay. But if you think scientifically, then it is much older. Because if the concept of multiplication is there, then how that thing would have been done? It cannot be done in vacuum. So that means the place value and the decimal place value would have been even much older. Okay. See, now I am giving the evidences from European and then from the Arabic. This is much later. Isn't it? So Sebok is giving in 700 AD. Isn't it? So that means by that time it is known, but people would be traveling much before that. No, so he says that means it is known long before that. So even like the Bakshali manuscript and so on, they say it was 100 AD or 100 BC kind of thing, and that time things are developed. No, it is developed 2000 years before that, because that is a collection of some results. It cannot be that the person who wrote that manuscript, he himself invented everything. So if you look at all these things, so maybe I can go to now Indian evidences, that graphical forms which was mentioned by Al-Biruni. So this is another thing. If you look at all parts of the Indian subcontinent, like starting from Kashmir to Tamil Nadu to Gujarat to Assam, in every place you have local tradition, or you can say vernacular language, in which you write the numbers. So I think people are here from different regions, and you can appreciate that. Let me start from the beginning. So that is, first one is called Nagari figures. So this geographical area is the present day Uttar Pradesh, Madhya Pradesh, Rajasthan, Himachal Pradesh, Haryana, etc., Delhi. And here you can see the different forms of writing down the numbers 1, 2. I have written several because, and here you can see some variation also, like this. In some place 4 is written like this. Similarly, the 5, if you see, it is written quite differently. For example, when I was studying in school in about 45-50 years back, we used to write 5 like this. Yeah, so I will show Kannada also. Yeah, I will show that. So 6, 7, 8, 9. 9 you can see so many versions are there. 0. So I think those who have studied in vernacular languages, some of you can identify. And depending upon the region, like let us go to next one. Anybody from Maharashtra here? Yeah. So can you identify this? If you have studied in Marathi, so like for example 5 or say 7 or 8 or 6.
Actually, we write like Nagari figure.
Nagari. Yeah. So actually, what I am showing, it is not complete list. It is some sample from every region. I have collected certain sample, and that is what I am showing here. But I think certainly you can identify many things here. So this is Marathi figure, which is in the Konkan, Goa, Daman, Maharashtra, and so on. Then something called Punjabi figures. So from the region of Punjab, I don't know whether any person is there from north. Yeah. So Punjab also has several, not one. We'll just show some more. This is one. I have named it differently because I have taken from a text. So this is called Sindhi figures. Then you have Gurumukhi, which is again Punjabi only. The last one, if you see. Anybody can relate to this last line? The last line, can anybody relate to this? Kannada will come. Okay. Hyderabad in Pakistan. Gujarat. Dipesh ji is not there. Something called Kaithi figures. It is written here Bihar, Gujarat, etc. But I have seen this thing actually by people who keep ledger. Actually, in the shops, I used to see in our village, the shopkeeper will keep a book of account, and there he will write in Kaithi figures. So it is usually by those people. So these are the figures. Then the people here from Bengal. Yeah, so you can identify some of these. Then North Bihar, that is Maithili figures. I don't know whether anybody is there from Maithili region. Then I have put Odia figures here. Odia, anybody is from Odisha? Yeah, this I have drawn, but I have taken from some sources, but I have drawn it here. This by hand I have drawn. Yeah. It is there it is there in some manuscripts.
You know, people in Marwar area and also in UP area, they use the Mudia language.
Actually,
you would
Kaithi and Mudia, they are used by these people who
business people, Marwari people,
Yeah, Mudia also, as well as this Kaithi, both.
Yeah.
And I have seen that
Yeah, I have also seen that.
Yeah.
And actually they have these, long बही होती है ना, लाल रंग का यूं ऐसे उठाया
हाँ,
and
वो
that is
लाल
how.
रंग की रखते हैं रजिस्टर।
हाँ जी, हाँ जी. वो नंबर 1 के अकाउंट ये
correctly
होते हैं,
pointed.
नंबर 2 ये होता है,
Yeah,
those
yeah.
kind of
You
all.
have pointed correctly. Yeah.
Yeah, yes sir.
So I have, this is a sample actually. Even the text from where I have taken, they have listed many more. So, but I have not listed because this is to be drawn and then scanned, etc. So I have done only this one. Then there are certain figures which are used in the, which is a variant of Dogri basically. This is called Takari figures. Again, these are used that Kashmir and Punjab. That is called Sharda figures. So Sharda figures, I have put so many of them, like 1, 2, 3. So many of them are there. Okay, and 0 is written as dot dot dot. Then Nepali. By Nepali simply we mean that this is also Indian subcontinent only. So I mean they are all not distinct actually. So these are Gurkhali figures. Then this is Tibetan figures. So there is another theory which was propounded that since in Tibet also, so whether it came from the Chinese, but Chinese themselves did not have this because the Chinese figures are quite different. So that means that hypothesis is false. So Tibetans were influenced by Indian. I mean, basically Tibetan region and all, because there was a lot of travel at that time. Now only it is separate this one. Anybody from Tamil Nadu? You are there. So in the ancient Tamil, 0 was missing, which also shows some historicity of this one, that probably is of even older origin. Okay. So Malayalam and Tamil, they do not have 0 symbol there. Okay. But again, you can see that Malayalam and Tamil, they have different scripts here. So which shows the different kingdoms were there. And you have, one was Chair kingdom and another was Chowl kingdom. Then Telugu figures, now you can see 0 is there, and I think Kannada figures are here. So certain things which I have not presented here, but they are available in the manuscripts. They are the Singhalese, so that means the something which is present in Sri Lanka, Burmese, the present day Myanmar. So they are all part of the extended Indian subcontinent actually. Then Thai, Khmer, Balinese, Javanese figures. So those who have done little bit of contemporary history, you know that the Indian civilization extended up to Southeast Asia actually, isn't it? Yeah. Now this is about the presentation of the symbolism, that means the place value system, how it is used. So now I have come to the modern times, I can say. So by modern time I mean from maybe like 200 BC or 300 BC onwards. So that is modern time for me. Okay, and because we are starting from the Harappan or Mohenjo-daro civilization, so that is Indus-Saraswati civilization. So that means they are the older times, and anything which is which we study, that means the history which we study in schools present day, which starts from Buddha and Bimbisar and Ajat-Shatru. So from that time I will consider modern times. Okay, so now from that time onwards, Sanskrit became one of the most important languages. Okay, so I think those people who are working in the ancient manuscripts and all, we know that now about 1 million manuscripts are available, which have been discovered in various parts of the country, and I think more than 80% of them are in Sanskrit, isn't it? And of course, there are manuscripts which are available in other regional languages also. So now the latter part of the research, or you can say the Indological research, has shifted to the knowledge of Sanskrit and then interpreting from there that what does it contain. So now coming to mathematics, again we are doing the same thing here. So let us look at that in the Sanskrit shlokas, how the numbers are represented. So for each number, they have used different synonyms. So let me just present these things here and with a few examples actually. So for example, the number 1, it is having the name Eka. Okay, so it is having synonyms as Pitamaha, Adi, Tanu. Tanu means body, Chiti, Earth, Abja, Indu, Soma, and so on. That means the things which are one, they can be used as the synonyms of the number 1. And in Sanskrit shlokas, when the numbers are represented, they have used this. So I will show some examples. Let us firstly read this. Then let us read 2. The number 2, the common name in Sanskrit we say Dvi. Okay, so you have Ashwin, that is the horseman. So 2 horsemen are there. Ashwin. It is also Ashwini Kumar, that is also 2. Then Yama, that is the primordial couple. Then you have Yamal, Yugal. So again, this is twins or couple, etc. You have 2 eyes, so Netra, Bahu, 2 arms. Then you have Gulfau, that is the ankles. Then you have Paksha. So Paksha, again it has 2 meanings. Wings, for the birds it is the wings, so 2 wings, or it is the Shukla Paksha and Krishna Paksha, that is the fortnight, 2 fortnights in a month. So Paksha is used for Dvi or 2. 3, that is 3. So in Sanskrit we say 3. So we have 3 guna, that is the 3 primordial properties, that is Satguna, Rajoguna and Tamoguna. Then we have 3 lok, that is you have Patal lok, Akash lok and Prithvi lok. 3 kal, again Bhavishya Bhutkal, Vartman kal. Agni, that is fire. Hara Netra, that is the eyes of Lord Shiva. So we say he has 3 eyes, isn't it? Chatur is the 4. Chatur Disha, so you have this Uttar, Dakshin, Purva, Paschim. Chatur Sindhu, Chatur Yuga, that is Satyug, Treta Yug, Dwapar Yug, Kali Yug. Chatur Irya, Haribahu, 4 arms of Vishnu, 4 faces of Brahma, that is Brahmasya. Then Pancha, that is for 5. Panch Bana, the proverbial Panch Banas of that Kamdev's thing, arrows. Panch Indriya, so we say that, no. Panch Tattva, we have Chiti Jal Pavak Gagan Samira. 5 faces of Rudra, Rudrasya, Panch Bhuta, Panch Mahayagya. Shat, Shat Ras, Shat Ang, Shanmukh, that is the 5 faces of Kartikeya. Sapt, so we have Sapt proverbial Ashwas, Sapt Naga, Sapt Nag, that is the 7 mountains. Then we have Sapt Rishis, Sapt Swara, Sapt Sagar, Sapt Dvipa. See, this is another thing. If you look at the Sapt Dvipa and try to think scientifically, if you say Sapt Dvip, that is the 7 continents, that means the existence of Antarctica was known. Okay, so I think one has to appreciate that part. It is not a latter day invention. Then Ashta, Gaja, Naga, Nag, Murti, Nava, Anka, Graha, Chidra, and so on. 0 is Shunya, Bindu, Kha, Gagan, Akash, Ambar, Vyom, and so on. Now this is not an exhaustive list, because Indian scholars, they have used diverse items for synonyms of numerical symbols. These symbols are all taken from nature, human morphology, animals, plants, everyday life, legends, traditions, religions, attributes of the divinities of Vedic, Brahmin, Hindu, Jain, Buddhist pantheons, and diverse social conventions. Again, it shows that the usage of mathematics in the advanced form is very much prevalent during that time. Otherwise, these things would not have. So I am just giving some example here. So this is from Surya Siddhanta, okay. So Shlok, it will be difficult for me to read it here because it is written in English version of it. So if you translate it, it says the upsides of the moon in a yuga, and the sequential terminology that is there, it starts from fire, that is Agni, vacuum, that is the Shunya, Ashwin, that is the horseman, then the Vasu, then serpent, that is the Sarpa, then you have Arnava, that is the ocean, and its waning mode again Vasu, fire, primordial couple, horsemen, fire twins. Now for Indian astronomers, these represent the numbers 4,88,203 and 2,32,238. So if you consider the translation of the, let us see how the place value system is used here. Let me put them in the order. The first term is Agni, that is 3, Shunya 0, then Ashwin is 2, Vasu is 8, Sarpas are 8, and Arnav, that is ocean, is 4. So you put it like this in the same order, 3, 0, 2, 8, 8, 4. And you convert it into the place value system, that is 3 plus 0 into 10 plus 2 into 10 square plus 8 into 10 cube plus 8 into 10 to the power 4 plus 4 into 10 to the power 5, and it becomes 4,88,203. Let us see the second one. Vasu is 8, then Agni is 3, Yama is 2, Ashwin is 2, Shiki is 3, Dasra is 2. Another important point which you should notice here, that in the same shloka, for example, 2 is coming 3 times here, but they have used 3 different synonyms. They have not written Yam, Yam, Yam 3 times, or they have not written Agni, Agni 2 times. They have used different synonyms. That shows an advanced stage of understanding and the usage of these. So if you convert it into the using the place value system, it becomes 8 plus 3 into 10 plus 2 into 10 square and so on, which number translates to 2,32,238. So this shows that there is a perfect understanding of 0 as well as the place value system, which uses the decimal as a base, that is 10 as a base system. It's a type of symbolic representation subject to many variations, yet the numerical symbols were always perfectly comprehensible to the Indian astronomers. Even if the value of certain words could vary according to the author, the region, or the time when they were written, the context always confirmed the intended numerical value. So I'll just give certain more citations from Southeast Asia, etc. So this is a inscription from Java. So present day Java, it is in Indonesia, and there is a Shaka date. It is in the state of Changal, and it is written as Shruti Indriya Rasayar. That is the inscription found there. So let us look at the translation of this. So Shruti means Veda, so there are Chatur Veda. Then Indriya, that is 5, and then the Rasayar, that is the 6 senses. So you translate it using the place value system. So it becomes 4 plus 5 into 10 plus 6 into 10 square, that is 654. So if you convert it into the Christian era, you add 78, it becomes 732 Christian era. So this is an inscription in 732 AD. It is from Java. Then you look at another inscription from Champa. Anybody can tell what is Champa? Cambodia. So it is in the state of some Meson, and the Shak data is written as Anand Amrit something. So let us look at the translation of this thing. So 6, so I have written it in reverse here, 9 plus 0 into 10 plus 6 into 100, it becomes 609 plus 78. So this is even older than that, that is 687 AD. Then there is something from Cambodia. So probably Chamba is, I think, Vietnam, most probably. So the next one is Khadvishara. So you look at this one, 0 plus 2 into 10 plus 5 into 100, that is 520 plus 78. That is the 598 AD. So this proves that the use of Sanskrit word symbols, it had spread to all over Southeast Asia in the 6th century itself. Again, I want to show certain continued tradition also. The continued tradition means that, as I said, that from ancient to modern, so there is no break of mathematics actually. So you look at I have listed here the text here. So Trishatika, it is by Sridharacharya. Date is unknown, I have written here, but most probably it is in the 6th or 7th century. Then Karnadi Patyati, it is 8th century text by Puttu, it is from Andhra. Then there is a Siddhanta Viveka, it is by Kamlakar, it is 7th century. Then Siddhant Darpan by Neelkant, it is 15th century. Then Drigantika, that is by Parmeshwar, it is 1431 CE. Then Vakya Panchadhyayi, it is 14th century. Then Siddhant Shiromani, this is of course Bhaskaracharya, 1150. Then Raj Mraganka, that is by Bhoj in 10,042. Siddhanta Akshara, that is by Sripati, 1039. So you can see from all the years, different years we have seen that these are all available. Another thing which I want to show, that it is not that they are using these numbers only for some recreational purpose, that they have only certain very small numbers or some useful numbers only. They are used for various purposes, and it will be clear if you see the first few examples that I will show you here. So you look at this example. This is from Bhaskara 1. Okay. So they want to say a Chaturyuga is made up of these many years. Okay. That is something like 43,20,000 years. Okay. So how he is writing this one? So it is written in the shlok form like Vyad Ambar Akash Shunya. Again you see this 0 is used 4 times, but this 4 times 0, he is using 4 different names here. So Vyad Ambar Akash Shunya. And then of course Yama and Rama and then Veda. So if you look at this one, the translation becomes 0, 0, 0, 0, 2, 3, 4. So using the decimal place value system, it will become 43,20,000 number. There is another one example from Bhaskara, which is actually in the commentary on Aryabhatiya. So again there is a big number here. You look at this. This is a 10-digit number. So that means in astronomical calculations, they have used very large numbers also. This is a 10-digit number. But another important point which I think one may miss here, this is this one. You see, he is writing 0373, and I told you the synonyms for 01 to 9. But there is a synonym used for 12 also. Which Sankhya Paddhati? Yeah, maybe, yeah. I don't know that. Yes, yes, yes. Yeah, Mahesh is ancient Indian mathematics.
उसमें भी एक चीज है कि जो व्यावहारिक संख्याएं हैं उनका उपयोग साहित्य के अंतर्गत किया जाता है, हो सकता है।
So the purpose of presenting all this is actually just to show that various regions of India, in various traditions, in various languages, everywhere mathematics was used. So you are giving an example from Surdas. So that is a Sursagar, I think, this one which you have told. So it means that, see, we cannot say that Surdas was studied in a university or somewhere.
सर ये वो एग्जाम्पल है कि जिसमें जब
Can you repeat again the example which you said?
कहत परदेसी की बात गोपियां कहती हैं कि जो चला गया है विदेश में परदेसी, उसकी क्या करी जाए? मंदिर आराधा आवाध बदि हमसो हरि आहार चल जाए। मंदिर का आधा हिस्सा पाक कहलाता है, तो पक्ष यानी 15 दिन का वचन लेकर गए थे। हरि आहार यानी मास अर्थात माह व्यतीत यानी 30 दिन होने को चले गए, और अभी तक लौटकर नहीं आए। इस तरह का आगे और हाँ, 15
He is talking to Uddhav, I think. Gopiya, they are talking to Uddhav, and he is telling all these things. The another one is there, na, that Uddhav man na bhai 10 20. So again 10 20.
इसमें आगे भी है नखत वेद ग्रह जोरी करत अर्ध सोई बनत अब खात 27 नक्षत्र 4 ग्रह और सॉरी 9 ग्रह 4 वेद इनको जोड़कर 40 उसका आधा 20 अर्थात विश्व वही अब खाते हुए बनता है।
So you can see this is very interesting actually. Yeah, we have read it in school, but now I don't remember. So she has told it very clearly. So you can see the jugglery of numbers along with the corresponding, like half of that is bees, and then they are saying it is wish. So I mean that kind of thing cannot be there unless you have a very developed mathematical understanding. So I think the point is very well made here. Now this example is again very important one, which I am showing. Here you see Kha is for 0, Agni is for 3, then Adri is for 7, Rama is for 3, Arka. See, this is 0, 1 to 9 we are saying, but they have used a synonym for 12 here. That is a 2-digit number. We have this Dwadash Aditya. So for 12, that is the sun, they have used 12 here. And then Rasa. But then again somebody may feel that they will make a mistake in the calculation. But if you see this here, 0 plus 3 into 10 plus 7 into 10 square plus 3 into 10 cube plus 12 into 10 to the power 4. But it is understood that it's a 2-digit number, so 10 to the power 5 is not there. And the next one you can see 6 into 10 to the power 6. So they have taken care of this, okay, which translates to this particular 10-digit number. So it is surprising to see that in a place value system, word symbols denoting values higher than or equal to 10, they are also used to express a number which contains 2 orders of units. And the value, this 1986123730, and it is clearly indicated in figures according to the place value system in the next line of the Sanskrit text, which accompanied by the words. It says in figures it reads, and they have written the corresponding this one in order to prevent any ambiguity. And there is another example where Bhaskaracharya has given Sanskrit as well as the corresponding numeral notation. This is a very big number. You can see this is, I think, this is a 19-digit number. This is a 19-digit number which is there in the Bhaskara's this one description here. Okay, so there are examples from Varaha Mihir and so on. There is a Jain work that is called Loka Vibhag, that is the parts of the universe. And here they have used like -1 is represented by Ruponaka. Okay, so that means the concept of negative integers was there. There is a number which is represented like 14236 that is an 8-digit number. So that is another one is called dating of the Lok Vibhaga. So this dating has also been done through a shloka here. The shloka is given here, and if you translate it, it turns out to be 380 Shak year. So if you add 78, so that is coming to 452 Christian era.
Sir, namaskar. Sir, I have only one question here. See, as we can understand that we were great, we did this and that, many things, and said it is from India and all those things. What was the enabling factor there at that moment? कि जो our idea has to be हम आज क्या है और कल क्या करने जा रहे हैं. what we are today and what we are going to do. So what was the enabling factor there which got missed out during the period? Now what we have to create here so that we can again be great. I believe that one of the idea of the IKS is कि हम खाली उसमें basking in the glory नाम हम ना करें कि हम महान थे. Question है how we can become महान now in today and tomorrow. तो ये मैं थोड़ा जानना चाहूँगा सर. Thank you.
So I think first thing that I would like to say that there is a great misconception that something has gone wrong or something. See, it only happened, I will just tell you. See, when the colonial period came, then the wealth of the country was sent outside. So country became very poor. That is the only thing that we can say. It is not that knowledge became poor or anything else became poor or scientific development became poor. No. The shipbuilding industry was there that time also. In fact, if you look at the Maratha shipbuilding industry and so on, it was there, and even when the Britishers have come, even in the Bengal also the shipbuilding industry was there. So things were there. It is only that the wealth of the country was transferred to England, and therefore the country became poor. That means the common man became extremely poor. When India became independent, they hardly had anything. I mean, there was no money. I mean, the GDP that time, if you look at, there was nothing, and so you did not have the food grains. They destroyed the industries and so on. So if you look at the scientific thing, it became subdued because of the gross poverty and the gross, you can say, deprivation of the population. So something, I think, if you read the things, probably things will become very clear. The development of the science continued. In fact, what we call Renaissance period and so on, but it was actually a continued tradition only. What we say that when the British universities started, like in Calcutta, Bombay and all these places, and then again, no, it is not because of that. It was already there, because now we are going through the literature which is available now. That means what mathematical developments are there and other things, they were being done that time also. So it is only some sort of misconception that we will become great one day and so on. There is nothing to become great. Actually, the knowledge is there, and actually, because this is a limited time, I cannot present. So if you look at last 100 years itself, how much mathematical contributions Indians have made. So I could not present all those things, because this requires maybe another 3 hours time. See, because we start from the ancient one and we cannot go to the new things which are there. So this is, for example, Ramanujam's mathematics. So you will say that where from Ramanujam is studied. See, Ramanujam did not have very good formal education, because he was passionate about mathematics itself. And in mathematics, then he continued doing. Of course, he got an opportunity of going to Europe, so that his work became popularized. But it does not mean that the G.H. Hardy or Littlewood helped him to prove anything. He in fact proved everything. They only helped to popularize it, so that the results came in open. Later on, entire of his manuscripts, they have been proved by two American mathematicians, that Bruce D. Bunt and George Andrews, and they have published some 12 volumes. He has proved around 5,000 results. 5,000 results, and out of those 5,000, only maybe 10 results were not correctly proved. All other 4,990 results are correct. So he made monumental contributions, and this is, so he is considered one of the greatest mathematicians. Now you will say, what after that? So Ramanujam is one, but then there is a full tradition. So for example, in the mathematics, we have a fully school of algebraic geometry, those people who work in algebraic number theory and so on. They have published great number of results. The evolutionary algorithm, I think it was proved in 2014 or 15, which is now considered to be the number one result in the world, because of the highest. It has more than a lakh citations actually. And Professor Kalyan Mahdev, he was alumnus of IIT Kharagpur. Now he was working in IIT Kanpur. Now he has gone abroad. So he has proved that thing.
Artificial intelligence, blockchain, all these ideas are coming from the West. Why not from India?
Not necessary that all are from West.
No, but sir,
as I mentioned just now, evolutionary algorithm is an Indian thing. The Karmakar's algorithm.
Are we, sir? Are we? हमारा हम यहाँ पे क्यों बैठे हैं, sir? We are here in IKS. because we want to feel happy that we have a great genes, we have a great past, and we have to go again great, so that how many more and more Nobel Prizes and other things are coming from India. I believe it is one of the idea of our investment over here. So how we can do those things, like medical transcription and artificial intelligence. जी जी okay sir. Sure.
I think we won't read much. See, entire area of sample surveillance that is developed by India. The current sampling theory, which is used, the sampling methodology, which is used worldwide, most of it is developed in India, and it was done in 1930s and 40s by statisticians which were led by P.C. Mahalanobis here in who established Indian Statistical Institute, and I can show maybe some quotations are there. Maybe we always look for certain approval from Western world. I think that may be the reason. Otherwise, we have done that. So most important contributions are related to the large scale sample surveys. He introduced the concept of pilot surveys and advocated the usefulness of the sampling methods. So this includes the topics such as consumer expenditure, tea drinking habits, public opinion, crop acreage. Harold Hotelling, he was an American statistician, he wrote, no technique of random sample has so far as I can been developed in the United States or elsewhere which can compare in accuracy which is described by Professor Mahalanobis. R.A. Fisher is considered the founder of statistical methods, and he says that Indian Statistical Institute has taken the lead in the original development of the technique of sample surveys, the most potent fact-finding process available to the administration, and so on. So I will not get too much into this thing. Let us look at other things also. I mean, what I am just saying, see, because of the colonial subjugation, we became deprived, like our country became very poor. So when country becomes poor, then knowledge, science, academics, that takes a back seat because survival itself becomes a thing. Now, see, we have spent almost now I think what is this Amrit Mahotsav, 75 years. 75 years. So already the economy has come up to a certain level. You have now schools, colleges, universities all over. See, when there was a survey done in the 80s.
सर बट रिजुवेनेट करने का इंटेलेक्ट तो हमारे पास वाज एग्जिस्टिंग थ्रू आउट नो अगर वो हमारा फंडामेंटल था दैट वी हैड अ वेरी शेप्ड सोसाइटी वी हैड गवर्नेंस नॉर्म्स वी हैड ग्रोथ पैरामीटर्स तो वंस वी आर इनटू अ शैलो फेज ऑफ इकोनॉमी तब भी अगर हम वो पॉलिसी डिसीजंस लेते या
उस समय तो हम नहीं ले सकते ना बिकॉज़ इट वाज वी वर नॉट रूलर्स नो सो दैट टाइम वी वर नॉट द रूलर after colonization things are happening no like if you start from 1947 onwards so what has happened the education has been given lot of importance and that is why things are happening no so what I am saying is that we should not see people are having some sort of feeling that why they are doing see you look at what you are doing isn't it why that is not
and as far as patenting or IPR regime is concerned sir whosoever makes the first take on them, they get the rights. So, how are we going to defend it? I mean, zero is protected, haldi got protected, neem got protected, basmati got protected because it's a transient variety of basmati that has been patented by somebody else. So, how do we go about further into publication and preservation of this legacy? I mean, would it pass into the folklore and get automatically protected या GI बन जाएगा because copyright I think is going to be difficult because the original scripts and the original authors they are not there so a copyright and 100 years after they die to their survivors that is out of question so अब हम क्या करेंगे sir patenting also is not possible because the original people who had formulated that patent they are not
no you have to defend it actually there are policies even like things made up of haldi or these kind of things which were being patented in USA but then it was defended by Indian scientists and now the patent has not been granted to them but to the Indian things so actually you have to fight see it's not a word which is ideal word. It's a, you have to come up and say things. If you don't say, then see, for example, I am a statistics person. I publish research papers, isn't it? And we publish in all the journals which are supposed to be good journals. Like you have some list of journals where you should publish. So suppose I say, no, I am great, I won't publish there, I will publish my own thing. Then nobody will recognize me, no? See, you have to fight at the equal level. See, like you say that now World Cup football is being played, okay? Indian team is not there because it doesn't qualify in the top 32 countries, whatever, isn't it? But you cannot say that, no, we are great players, we have great players, and but we don't play there. So how will you show? So you cannot, I mean, so why not India starts its own procedures? Isn't it? Is it not possible for
Sir,
India?
वो
But
universally acceptable है. So designing a
no, that is
parallel
what you have to come up with
mechanism.
that thing. See, for example, you look at, see, I will just give very simple example. You look at the game of cricket. Okay, the cricket was a domination of England and Australia, and till 70s, like when we were children, so England and Australia, they were the top always. Whatever policies are there, the meeting will be held in MCC in England, in the, what is that, Lords, and so on. So there was some sort of subjugation, like Indians, they are useless. I mean, they are all okay. They also play, but one player may be good, but all are, the country itself was considered to be weaker. But what happened after 1983? See, we have defeated them there, and now where is India in the world of cricket? I mean, whatever India says, that has to be followed. So because you have created a system where you are making the rules, isn't it? So unless you become great, let us take another example. Now, till 1950s, 60s, 70s, what was the status of China? Unnoticed means it was considered backward, poor, and all that kind of thing. 1977 onwards, they went on a liberalization drive, and then they have developed. But what they
Our
have done,
perception about the batteries changed. पहले
ये होता है अप्स और डाउन का, ठीक है। आप देखिए अभी भारत में वो था, अभी वो नहीं है, लेकिन हम लोग अगर साहित्य में जो डायस्पोरा स्टडीज होता है वो उनके नजरिया में अगर देखें तो भारत के लिए काम सिर्फ भारत में बैठ के नहीं किया जाता है, बाहर में जाके भी किया जाता है। ये है डायस्पोरा स्टडी। तो रहते हैं बाहर लेकिन चिंतन होता है भारत को लेके। तो ऐसे ही तो चल रहा है। अभी जो आईटी इंडस्ट्री देखे और भी ज्यादातर देखे तो हम लोग सोचते हैं ये 100 बरस में 200 बरस में भारत पिछड़े हुए हैं, लेकिन ऐसा नहीं। आप 1000 बरस में देखिए, क्योंकि हम लोगों का जो कॉलोनियल हिल्स था वो तो था 1000 बरस। तो हम लोग सोचेंगे, बड़ा सोचेंगे, बड़ा तरीके से।
yeah, I mean, I think there are a lot of points, but I will just end with one comment. So please study, study books, study literature, and see things at various places. Do not make your thoughts based on few WhatsApp forwards or Facebook messages. Okay, please read originals, read books which are available in India and other elsewhere. Read what others are doing. Read what we are doing. Since when I took up this ICAS and so on, I have been reading a lot. See, if you read, like, I think that professor, he asked the question about why we are not doing things. I think we are doing, but see, unless you read about what we are doing, then we cannot say what we are. I just presented few things, but I can present another 100 things. But you have to actually read ourselves. Otherwise, it is only like what I am saying, then you have to understand that. Okay, so
Thank you.